Hello. So today's topic is central angles and arc measures. So these are another really big staple for what we're going to be doing for the entirety of the unit. And so we really want to have a good foundation here, but it's actually really simple. So a central angle, by definition, is an angle with its vertex at the center of the circle. And its two sides go from the center to the edge of the circle. By definition, that's a radius. So the two sides are radii. Which again, is just the plural form of radius. So whenever we see one of these central angles, it's going to be measured in degrees. And if we add up all of the different central angles in this circle, if we added up ABC, and if we drew a line and added ABD and DBC, all of those angles together would add up to 360 degrees. Now this one is super important. The degree of the arc formed by the endpoints of the central angle. So if we look at angle ABC, the arc formed by the endpoints would be this arc here, AC. The degree of that arc is equal to the degree of the central angle. So arcs on circles are measured in degrees just like angles are because of that relationship between them. Now, don't get this confused for arc length. The length of the arc can be different. It all depends on the size of the circle. The arc length would be a portion of the entire circumference, but the measure is measured in degrees, just like the angle here. So if ABC is 84 degrees, that means that arc AC is 84 degrees. So let's look at how this looks with some numbers. Now I made a typo here, so I'm going to correct this statement right here. This should say the measure of angle ABC plus the measure of angle ABD plus the measure of angle DBC. So those were those three angles I talked about here if you were to draw a line from B to D. And that would be all the different angles in the circle. So let me draw kind of a version of it over here. So this is kind of what we're working with from here. We know that this one's 84 degrees, but it actually doesn't matter. We don't need to know the measure of the entire circle by its parts. We can just know that all of these together, because they all form that circle, is going to make 360 degrees. Whether or not I know every single individual measure doesn't matter, as long as I know they all come together to make that circle. If I were to start at one angle and make an arc, and then go to the next angle and then go to the next, if I make a whole circle, that's 360 degrees, no matter which way you cut it up. So this right here is demonstrating this point here. The sum of all central angles in a circle is 360. These were all three central angles. They all add up to make 360. This is used to find many different angles in the circle. We use this, I call it the rule of 360 pretty often, to be able to find the other measures in the circle. Now, what would be the measure of minor arc AC? That was the one that we highlighted in the picture above, and its central angle was 84 degrees. And I actually already said that one. It's 84 degrees. So the measure of arc AC, whoops, that's the arc symbol. I accidentally put an equal sign. The measure of AC is the same as the measure of angle ABC, that central angle. And those are both 84 degrees. So this is demonstrating that the degree of the arc is equal to the degree of the central angle. And lastly, what is the measure of major arc ADC? So that's all of the circle except for the piece that's 84 degrees. Well, if I have a pizza that's cut into 8 slices and I take one of the slices away, what's the rest? Well, 8 total minus the one I took would be 7 remaining. The same idea here. If I take 84 degrees out of this circle and I know the total is 360, all I have to do is 360, take away the one piece we took, 84, and we will get the rest of that circle. So 360 minus 84 will give us 276 degrees, and that would be the measure of that major arc, ADC. So the reason that it's important that we differentiate between a minor arc and a major arc is because AC could be going from A to C this way, or it could be going from A to C the long way. And so because there's kind of two sides, because it's a circle, it's all circular, we have to differentiate that we're going from A to D to C the long way. And also by saying it's a major arc, we know we're going the long way. Just wanted to talk about that a bit. So let's do an example like how we might see it worked in some problems. So here we have a circle with two intersecting lines and an angle, central angle of 21 degrees. So first to ask, what is the measure of arc JK? Well, JNK, the angle associated with that arc is 21 degrees, so the arc itself would also be 21 degrees. So that's simple. Now what about angle MNL? MNL. That would be the other little skinny angle down here. Well, notice that I mentioned intersecting lines. Where there are intersecting lines, and I can only stress this enough, there are vertical angles. I included that in your warm-up for a reason. So if this angle is 21 degrees, so is this one. Vertical angles are great because you can figure out so much without having to do any math. And so of course the arc associated with MNL is also going to be 21 degrees. So there's a lot of samey same here. Now, what if I wanted to find the measure of angle JNM? Well, there's a few different ways you can go about it, but the main one I would say is if I have a straight line cutting through the center of the circle, that's the diameter. And so this would be half of a circle. Half of 360 is 180. So this angle, JNM, and this angle, JNK, will make 180 together. And just like I was talking about earlier, when you take away from the whole 360, you can take away from 180. And that would give us 159 degrees. So if I know that this half a circle comes out to 180 degrees altogether, and I take away this 21 degree piece because I want to know what this is, that's exactly what I did right here, just with math. So now I know this is 159. What about K and L? Now it might not be as easy to see because it's bigger. Sorry, my words today, because it's bigger. But these are still intersecting lines, so these two are also vertical angles. There's always the two pairs of intersecting lines. So we can't ignore the other pair. Boom, that would also be 159 degrees. And you could check yourself and make sure, do all of these add up to 360? That would kind of tell you if you went wrong somewhere. But regardless, back to this, measure of JNM, that arc, JNM, nope, that should just be arc JN. I made a lot of typos on this, huh? Anyway, the arc associated with angle JNM, arc JM, would be the same as the angle, 159 degrees. Now, there's one other thing that we might have to do when we're working with central angles and arc measures. And that might be that we have to add pieces together. So here we found individual pieces. We found this individual angle and this individual angle, this individual arc, etc. But what if they wanted to know arc JKL? That would be going from J to K to L. I would have to add pieces together. So I'd have to take that 21-degree measure and add the 159-degree measure. Now, we did this exact thing but backwards earlier, so it's going to come out to 180. But that's the basic premise here. You just have to add the pieces together. So let's try it again with arc KML. KML. So that would be a 21 plus a 159 plus a 21. And that would come out to 201 degrees. Now what about measure of angle JNL? Once again, this is adding the 159 and the 21-degree piece. So that's just going to bring us to 180 again. We could also see that that's half a circle. We could jump straight to that. But it will never fail you to just add the pieces together. And so that covers all the basic ideas here. The two major ones are that whatever the inner angle is also the measure of the arc formed by the endpoints of the angle. And all of these add up to 360 degrees. Now, vertical angles play an important part here, and having a good understanding of parts and wholes will also help. But that sums it up for this lesson. Again, if you ever have any extra questions, need any extra help, please send me a message. I know one video doesn't really encompass everything it needs to when you're learning a new topic, but I have to work with what I got essentially. But I'm here to support you if you ever need any more. All right, I'll see you guys next time.